Hello, everyone. Good morning. Thanks, Janice, to the opportunity to talk here to everyone. I'm Haroldo Tiexiera. I'm a data architecture consultant from Petrobras at Brazil, and I'm going to share with you a bit of the experiences that we have in developing an industrial data platform at Petrobras that we call Nautilus. Well, first of all, a bit about Petrobras for those here who doesn't know us. We are a 70-year-old government-controlled private company. We have several lines of business on oil and gas, from exploration, production, refining, transport and market, and gas and energy, and we try to integrate them whenever is possible. Some numbers that we have, these are 2023 results. We'll probably be hearing about our results of 2024 in a few weeks. But I like to point to our range of revenue, about $100 billion, investments predicted to 2025 to 2029 on the order of another $100 billion, and about 40,000 employees. And our operations are very diverse. We have from production rigs, refinery, thermoelectric plants, let's say vintage oil and gas, to something more modern, something more on the renewable energies side with biofuel plants, wind power, and solar energy. So what's our challenge now that we are dealing with data platforms? We need to accelerate analytics and AI solution. We have to reduce our mean time towards reality. I think that's the great point. And explaining this in one example that we have. 3 years ago, guys from the operation asked us, what happens to emissions on an oil rig when we change our operational conditions? For instance, if I turn down a compressor, what will happen to our emissions? And they try to solve that with mathematical equations. They try to solve that in traditional ways. So we decided to apply, guess what, AI. Everyone wants AI, so we try to make an AI solution. And we did it. We spent a long time to develop a model to answer this question for one unit, one platform of us. And it was a success. Everyone liked it. We get an error rate much lower than the mathematical equations that we were working previously. But when you get success, you have new challenges. So people asked us, scale that. And we also took a long time to scale this solution to 5 other units. And why did this happen? Every time we talk about AI, everyone thinks that we need to train a model. They say, whoa, train the model, that's incredible. He will think, he will guess, he will infer everything for you. But to train a model, you need data. You need to get data from several data sources and make it happen. And to get this data, first of all, you have to map all your data sources that are useful for that domain. And you also need to understand the data that resides on these data sources, and that took a longer time. And for prototypes, for MVPs, you need to extract this data, sometimes manually. In this case, we had to extract it manually from OSIsoft Pi. On the other hand, when your model is ready and ready to work, you won't give the model to the operator. You will have a console where you type their run model using this input file. This is not usable for any operator. So you need to turn that in an application, in a dashboard, in something that people on the operation can use. And we spent 20% of the time in the part that everyone says is the most valuable, train the model, get the model. 30%, these are approximate figures, not exactly, but 30% of the time industrializing the solution and half of the time dealing with data. And that's why we're taking so long to make it happen. And this was a case that we have success. We have several AI initiatives that you started to work and then discover that you don't have the data, you don't have a good description of the domain to work, so they fail. And then sometimes it takes 6 months to fail, and that's not good. When we talk about industrial data, we have some specific challenges here. Because when we are talking about, for instance, tags or time series values, you have variables, measurements that you make on your equipments. And you have some metadata describing these variables. But this information alone doesn't tell anything for you. You need to contextualize this information. You need to say which sensor or equipment is related to that variable. You need to say the location where that equipment resides. You need to link that to a maintenance history of that equipment. You need to tell this history of failures. And you also need to get some plan designs to see where this equipment resides, which is the connection to other equipments and things like that. This is a dynamic graph. It's not something that you see on traditional relational models because this changes from plant to plant, from operation to operation. So you need some way to define this in something that we call more as a knowledge graph, something more similar of what you have on a Facebook or a LinkedIn, where you have connections between the informations instead of relations and tables that you have on traditional IT systems. And to make this even more, let's say, have more fun, you have different types of data sources. You have sensors, you have historians, you have corporate systems, you have cameras, you have drones, you have lots of things that are generating information for us. You have different formats and time requirements. When I get a time series, for instance, I have a graph like value against time. When I get a maintenance order for an SAP, I have a table, something that looks like more as a spreadsheet. And finally, we have different latencies to get this data, from satellite communications that are a bit slower to, at Petrobras, for instance, we're starting to transmit well sensor data by means of fiber optics, getting data on a nanosecond rate. So we have both excess of data and sometimes difficulties to transmit data. So we are trying to solve this problem building the concept of data platform at Petrobras. And what we think that is a data platform. We have a huge library of organized data, a repository where people can find information organized by domains of informations that we have in the company, upstream, downstream, midstream, or corporate area. We serve this data to self-service analytics and AI tools. In Petrobras, we use a lot Power BI, Spotfire, AWS, and Azure AI solutions. We make the catalog of this information available in a self-service portal where people can browse for which information we have on our data platform. And when you click and want to use that information, we automatically provision the access for this data. For instance, if you're building a Power BI dashboard, when you get the access for this information, we provision automatically all the access from Power BI to our data platform. And sometimes, and at the beginning, a lot of times, information is not yet on the platform. So you have to ask someone to make this information available. We created the concept of data teams, teams that blend people from the business and from IT to understand data sources, understand the meaning, and load this information inside the platform. And we also have a very huge governance mechanism to make this thing grow in a sustainable way. If people started to load information here without a minimum of governance, this could become quickly a data swamp. We have built this platform for corporate data in the last 3 years, and from 1 year till now, we are instantiating the same concept for the industrial area, and we are calling this initiative as Nautilus. The idea is to have a fast offer of data with quality and meaning, and the simplification and automation of data provisioning mechanisms. The goal for us is no tickets for IT to get the data. That's our mission. The technology that we are using under the hood, we have our OT data sources, IT data sources, and ET data sources. Here are some examples of tools that we are using at Petrobras, SoftPy, SAP, and Hexagon. We have an integration layer that collects data. We have a centralized and contextualized data layer. Any coincidence with the previous presentation, I think that are not so aleatory. I think that everyone has the same problem. So we have a contextualized layer of information. We need an engine of transformations to bring information inside this layer. And finally, we have what we call a consumption layer. What's that? It's a place where our end users can get this information, work with that, filter, join, and specialize the information to solve business cases. For instance, to get the right set of information for a dashboard, for a specific application, or for an AI solution. The tools that we are using to do that, we are working on the data layer with Cognite to build this central layer of information. The integration layer, we are using several Cognite standard extractors, and we are also using Data IQ. That's also a tool to build pipelines where we can build low-code pipelines whenever we don't have a standard extractor from Cognite. And on the consumption layer, due to its self-service characteristics, we are using Data IQ because it's a very good low-code environment for people to work. The strategy to deploy that or goal is to have what we call a hub and spoke model. What's that? We have a central team on IT that we call hub that provides guidelines, provides governance, provides structure. And we have on the leaves the business areas populating our repository and using this information to solve business problems. But to get there is a journey. We can start that snapping our fingers. So we started an initial model with this core team a bit more, let's say, strong, with more responsibilities, learning how to deal with the platform. We have an intermediate step passing this protagonists to data teams to finally pass the protagonists to the business areas. So we have a shift of protagonism during the time. 2024 was the year of this first stage. We learned how this works. 2025 is the year that we are going to scale this thing. And 2026, our target is to democratize, to reach that state where the business areas can fully operate this environment. To deal with that, we count with some partners. We have SLB and Brillosoft acting, helping us, providing Cognite technology and Data IQ technology. And we also have some integrators to build solutions using these tools. There are Compass and Deloitte. There are the two companies at Brazil that help us with data solutions. The benefits that we already perceived, we apply this kind of solution in 4 business cases. And here is an important point. You don't build a data platform because you're building a data platform. You're building a data platform to solve business problems. And that's a mantra to our team every time we think about that. What problems of the company are we solving with this infrastructure? For the refining area, we get 2 business cases from them where they have AI solutions to measure quality, to predict quality of products in our refineries that were based on Azure classical cloud services. And they need to maintain about 15 to 20 different services considering storage, Azure machine learning, ETL maps using Data Factory, things like that. We reduce this complexity and now they have to deal with only 2 tools, Cognite and Data IQ. Second, we enhance performance of dashboards for valve management. We had a problem to detect failures on valves, and we have a dashboard to watch that. And these dashboards were presenting constant problems in performance, trying to get us a soft PI data and consolidate on a dashboard. We use Cognite to concentrate this information, make it more easier to handle, and then this dashboard has a huge increase in performance. Easier scalability for large machine monitoring for gas. On our gas area, we have several units that have different standards of representing data in their areas. We concentrate in one standard model inside Cognite, and then we can now scale and, for instance, if I define a metric for monitoring large machines for one unit, this metric can be reproduced in other units very fast. And finally, we have a huge project at the company called Asset 360, where we try to connect information from several formats, several data sources to have a full view of our assets. And we are starting to support them. We already connected Hexagon and SAP data And the next step is connecting our time series data from Nazisoft Pi. Some lessons that we learn. Contextualization is a key requirement, and we have some very cool features at Cognite to help us using AI for that, but it's not an easy task because you need, as any kind of AI solution, you need someone that understands the business to validate that. And we are in the process of educating our business guys to learn how to use this kind of tool. So it's not something that you snap your fingers and happens. Second, cybersecurity is a very important topic. When you place a data platform, you connect to OT networks, you connect to OT systems, and you have the risk of opening a new vulnerability. So you have to take care of not let an incident happen due to access to data. And finally, it's hard to find people with knowledge on industrial platforms. And why does it happen? The concept of data platform usually is an IT thing. And IT guys and I'm an IT guy, so I can tell that. IT guys usually doesn't understand well industrial data. On the other hand, the guys that understands of industrial data, the OT guys, usually doesn't understand of data platforms. So we have to blend these people and make them work together. And I think this is one of the greatest challenges that we have. And finally, our next steps. We need to scale that. We solved 4 business cases. We have more than 30 on our QE for 2025. And we think that we need to explode that to the data teams, started to work and publish content on the platform. We need to train more people and incentivize a partnership between solution providers and integrators. We cannot trust, even if I have the best partners in the world, we need more people to work with us. A data ecosystem is something so huge that you can't trust in one company or two to work with you. You have to bring everyone to this platform. And increase this depth of this ecosystem. Petrobras, for instance, has several contacts with several universities that can help us, especially in modeling, because when we are dealing with knowledge graph, we're starting to deal with things that academy knows very well, like ontologies, taxonomies, and they can bring data models that are more effective for us. So we need to enhance the partnership with these entities to make this really take off. And integrate more with our non-IT environments, talk more with IT. And especially, as I told you before, we already worked on the corporate area. We use their Databricks, SAP, and we're starting to use MS Fabric, so we need to talk with these environments. This thing must be seen to the end user as something, as a single experience and not as several platforms. So now we are trying to make this integration. And that's all. Thank you.